SpaceX is already racing towards Starship's next flight and its first genuinely operational mission to orbit, all while still in the middle of trying to recover the last one. Alongside that effort, the company has dropped a genuinely astounding preview of a new manufacturing project called Terrafab, mixed in with a steady stream of Falcon 9 activity, and even a previous Starship flight managed to make a significant impact again this week. On top of all of that, the rest of the commercial space industry seems to be picking up momentum on nearly every front at once, so there's a lot worth working through. It has been a genuinely packed stretch since Flight 13, with spectacular new footage continuing to trickle out well after the launch itself. One of the bigger threads has been the fate of the ship that flew that mission. After splashing down softly in the ocean, SpaceX confirmed it was sending out a dedicated recovery ship to bring the vehicle home, and new imagery, captured by commercial satellites and shared publicly, confirms that the ship is indeed still afloat above the Indian Ocean. Having splashed down just over 2 weeks ago now, it has drifted hundreds of kilometers away from its original landing point, carried along by wind and ocean currents, but the recovery team stayed with it the entire way. They eventually managed to get it hooked up to a tow line, attaching it at the aft end of the vehicle rather than the nose, which many observers had originally expected. The likely explanation is that the recovery team used the existing clamping interfaces between the booster and ship sections of the vehicle, structural hardware that's already built to handle serious load and happens to be well suited for looping a tow line around securely. Given how much the wind and wave currents are fighting against the tow lines, progress has been slow, even after days of active effort. The current estimated arrival point is a port in Western Australia, likely Dampier, though the actual timeline could stretch out over several more weeks depending heavily on weather conditions. A recent update from SpaceX made clear that things haven't been going entirely to plan. The team has been fighting increasingly rough seas while trying to haul the vehicle on this long journey, and footage shows large air-filled rubber marine fenders attached to the hull. Cushions, designed to help keep the ship floating properly for towing, while absorbing any impacts that could otherwise cause further damage along the way. Even though the recovery itself isn't looking especially promising at the moment, the effort has still been valuable, since it's given engineers an enormous amount of video and imagery of the heat shield to study and diagnose. It would be genuinely satisfying to see the vehicle actually make it home, and hopefully the team can keep the tow moving despite the conditions. That target port sits roughly 1,250 kilometers, or about 780 miles north of Perth, the Australian capital. The bigger open question is what actually happens to the ship once, or if it arrives. Will it simply be lifted onto a larger vessel and transported all the way back to Texas in one piece, or will a SpaceX team travel out to document it further and dissect it, keeping only the most valuable components for the trip home? Given that nobody has ever gone through this exact recovery process before, there's no established precedent to lean on, which makes it genuinely interesting to see where things stand in a few more weeks. It's worth sitting with why this recovery effort matters, even if the tow to port ultimately fails, because the value here isn't purely about bringing a piece of hardware home intact. Every hour that ship has spent floating in open ocean, exposed to sun, salt water, and wave action, is effectively a real-world durability test that no amount of ground-based simulation can fully replicate. Engineers get to see exactly how the heat shield tiles hold up under prolonged environmental exposure after a genuine re-entry and splashdown, which parts of the structure show wear and which don't, and how the vehicle's overall buoyancy and structural integrity behave over an extended period rather than just in the minutes immediately following splashdown. That kind of data feeds directly into decisions about tile bonding methods, structural reinforcement, and the design of any future recovery hardware, regardless of whether this particular vehicle ever makes it back to a shipyard. In that sense, even a recovery effort that ultimately gets abandoned partway through the tow still pays for itself many times over in the engineering data it generates along the way. The broader lunar lander race unfolding across several companies at once also deserves a moment of context, because it's easy to treat each individual update as a standalone story rather than part of a much larger competitive and logistical puzzle. NASA's strategy for building a sustained lunar presence has deliberately spread contracts across multiple companies rather than relying on a single lander design, partly to maintain competition and partly as a hedge against the very real possibility that any one program could face delays or setbacks serious enough to threaten a mission timeline. Seeing 3 different lander programs, each backed by a different company, moving through environmental testing, stacking, and final assembly within roughly the same stretch of months is a meaningful signal that this redundancy strategy is actually working as intended. If one of these landers slips its schedule, whether due to a technical issue, a supply chain delay, or a launch vehicle problem, the broader lunar program doesn't necessarily grind to a halt because other landers are moving through their own independent development pipelines in parallel. That kind of institutional redundancy is exactly the sort of unglamorous background planning that rarely makes headlines on its own. But it's precisely what makes an undertaking as complex as a permanent lunar outpost realistically achievable across a timeline spanning many individual missions and multiple different vehicle designs. Both the Super Heavy booster and the Starship upper stage assigned to that mission remain tucked away inside their respective assembly bays, being prepared for their static fire testing campaigns. A new temporary flight restriction has been put in place over the test site, running through the 20th of the month, most likely tied to the upcoming static fire for the next Starship vehicle, so that's worth watching closely. In the meantime, SpaceX's most recent quarterly earnings call offered some genuinely useful new information. The company confirmed it's still planning to go fully orbital on the next flight, which would mark the first complete Starship mission of its kind. They also confirmed plans to send a stack of fully operational third-generation Starlink satellites into an actual operational orbit, and, assuming everything goes according to plan, to attempt a tower catch of the returning ship for the very first time. At this point, the main outstanding hurdle isn't technical readiness, but regulatory approval for that catch attempt, so hopefully that process continues moving forward smoothly. Current indications still point toward a launch later this month. If SpaceX can successfully pull off both the orbital mission and the catch attempt together, it should meaningfully accelerate how quickly the overall launch cadence picks up from there. There's also been plenty of online debate about how close the vehicle's heat shield actually is to supporting genuinely rapid reuse, especially after a handful of broken tiles turned up following the last splashdown. During the earnings call, the heat shield was described as essentially a solved engineering problem at this point, based on what was observed during the last flight, although the company was careful to note that ongoing improvements will continue in order to fully support rapid, high-frequency reuse going forward. Company leadership also stated that within roughly a year, the goal is to have a Starship vehicle flying at least once a day, if not more frequently than that. It's worth taking a moment to actually put that ambition into perspective. Across the entire Falcon fleet, SpaceX delivered around 2,500 metric tons of payload to orbit over the past year combined. With Starship, the stated long-term goal is 1 million tons to orbit annually, and eventually even more beyond that. That number is far enough out on the horizon that it's not especially useful to fixate on yet, but running a rough calculation, if you assumed each flight carried around 100 tons to orbit, hitting that overall target would require something like 27 flights every single day. It's clearly a distant, aspirational figure worth setting aside for now, rather than taking too literally. It's more useful to think specifically about the goal of 1 launch per day within roughly a year's time. Even with a full fleet of Super Heavy boosters and Starships in rotation, already being reflown multiple times each, the real bottleneck likely isn't the vehicles themselves. It's the propellant and water supply chain required to actually support that pace. Reaching anything close to that cadence would require multiple active launch sites, meaning fully operational fleets in both Florida and Texas simultaneously. Looking at the current Texas launch site alone makes the scale of that challenge clear. After every single launch, the site has to be reset, and hundreds of propellant and water tanker trucks have to be brought in before the pad is ready to support another flight. That kind of turnaround simply can't happen in a day or two under the current setup. Even once the new on-site air separation unit and methane generation systems come online, systems that are still a good way off from being operational, that alone likely won't be enough to fully close the gap. SpaceX is clearly moving quickly across all of its launch site infrastructure regardless, so it will be genuinely interesting to see just how close the company actually gets to that cadence within the next 12 months. Even reaching a pace of a few launches per week would represent a massive achievement in its own right. Alongside all of that, the company also indicated that by the time it accumulates enough flight experience with Starship, likely by the end of 2027, it expects to have built up a safety record appropriate for eventually carrying crew. Things are clearly building toward a considerably more intense operational pace over the next couple of years. Ahead of the next flight, SpaceX also appears to be making targeted updates to the second launch pad. The crew was seen assembling scaffolding along the sides of the flame trench and welding in additional large burn plates, seemingly to reinforce sections of the trench interior. It's not yet clear whether this represents a permanent design change intended to be rolled out across every launch pad currently under construction, or simply a temporary fix specific to this pad for now. Given that this particular pad has only supported 2 flights so far, seeing design refinements at this stage isn't especially unusual. If it does turn out to be a broader design change, the good news is that every other pad currently under construction can likely have that modification incorporated relatively easily during the build process, rather than requiring costly retrofits later. Meanwhile, the transformation of the original Texas launch pad continues progressing at a genuinely rapid pace. One of the site's large mobile cranes has been fully reassembled and raised again after months spent in refurbishment. That frees up the second large crane on site to be lowered so it can be reconfigured into its taller operating setup. Once that second crane is raised again, it will be used to lift a newly built tower roof structure into place, a component that's been sitting nearby in preparation. Crews have already begun attaching this perimeter fencing around that roof section, suggesting it's nearly ready for installation. In a related update, after the final remaining section of the old ship's quick disconnect arm was sliced apart and hauled away last week, aerial photography now shows nothing left behind but a small pile of scrap material. Nearby, sections of the Drawworks hoist systems support structure, which had been stacked up beside the tower, are already being moved into position at the base, suggesting the large motor hoist system responsible for moving the tower arms should be back in operation before too long. A significant new steel section for the deluge system also arrived at the site this week, a component that spans directly across the middle of the flame trench and supports both the deluge bucket halves and the apex structure above them, matching the design already used at the second pad. Over near the vehicle assembly area, in front of the site's rocket garden, SpaceX has staged an assortment of components that appear to be intended for new Gigabay workstands. There seem to be pieces for 2 separate stands, along with a single set of walkways for one of them. Looking closely, one stand appears to include an opening size specifically for a super heavy transfer tube, while the other includes cutouts matching the upper stage Starship's single center transfer tube along with its 3 outer transfer tubes. These new stands should help speed up the overall construction process for future vehicles considerably. Separately, in preparation for eventually sending a Starship out for a launch from Florida sometime this year, the Super Heavy breakover fixture, previously under construction nearby, was moved this week over to a staging area beside the assembly bays, suggesting it's close to complete and ready for its first real use. Company leadership has previously mentioned that a slightly later flight could end up being the first to launch from the historic Florida pad, though that timeline still looks somewhat further out. Regardless, it will be a genuinely unusual sight seeing a vehicle laid down horizontally for transport for the first time, aside from the one currently floating in the ocean under very different circumstances. The large new assembly building on site, referred to as the Gigabay, has also come along significantly over the past month. The smaller crane working on the structure has been steadily completing the exterior cladding, with more than half of the building now covered. The 4 larger tower cranes above are quickly working through the final lifting operations, with the roof trusses now fully installed. Crews have even started removing a section of wall along the edge of the neighboring factory building in preparation for constructing an extension that will eventually connect the 2 massive structures together. Once the door at the back of the new assembly building is finally closed, the current open view into the vehicle ring construction yard will be lost for good, and a nearby alleyway currently offers one of the last decent glimpses into the interior of the second assembly bay. That view won't last much longer, though on the bright side, flight activity is expected to become considerably more frequent going forward, meaning there will still be plenty of new material to follow. At the separate structural test site, there's also meaningful hardware activity to report. A super heavy grid fin test rig, fitted with multiple actuators, was rolled out and positioned beside one of the work buildings on site. Nearby sits half of a grid fin structure with attachment points designed to connect those actuators, along with an accompanying motor, suggesting the team is preparing to put the design through a genuine stress test to confirm it performs exactly as expected. Separately, a brand new nose cone test article was lifted off its turntable and rolled out to the test site toward the end of the week, where ground crews quickly loaded it into the site's structural crush testing rig. To put into perspective just how long it's been since a dedicated nose cone test article like this was last built and tested, the most recent comparable example was repurposed years ago from an earlier production vehicle, after previous serial numbers destructive test ended prematurely. A great deal has changed in the years since then, and the list of items the team likely wants to stress test on this new nose cone is probably extensive. On top of all of that Starship-related hardware progress, SpaceX also announced its plans for an enormous new manufacturing initiative, internally referred to as Terrafab. The company shared an animation alongside a detailed written update, giving the public its first real sense of just how massive this facility could eventually become. Several different views were included, but one wide shot in particular showed a scale that would be genuinely extraordinary if it's built out as planned. The facility is slated for a location in Grimes County, Texas, with a finished footprint of around 100 million square feet, a staggering 9.3 square kilometers, or roughly 3.6 square miles. For comparison, that would make it something like 10 times larger than Tesla's biggest existing factory footprint in the same state. The design includes multiple highway interchanges connecting directly into a main road running through the center of the site, an unusual choice, and the overall concept mock-up looks almost otherworldly in scale. The core problem this facility is meant to solve is compute capacity. If demand for computing power continues along its current trajectory, meeting that demand is going to require a dramatic expansion in manufacturing capability. Anyone who follows consumer hardware pricing already understands how expensive certain components have become as demand has outpaced supply. Based on the framing SpaceX has used so far, the company doesn't appear to be positioning itself as simply another participant adding modest compute capacity to the broader market. It seems to be aiming to become a genuinely major player in this space entirely, particularly when considered alongside the services planned for the next generation Starlink constellation, and the company's even larger ambitions around data center infrastructure. The direction this is heading is genuinely striking to watch unfold. Turning to Falcon 9 activity, the first mission of the week lifted off on a Tuesday morning from the frequently fog-covered Vandenberg Space Force Base, carrying another batch of Starlink satellites. True to form, the fog meant that only the sound of the engines and a faint orange glow through the mist offered any real clue that the rocket had actually left the pad. SpaceX later shared several clear photos regardless, and the booster flying that mission, a well-used veteran now on its 34th flight, touched down successfully on a drone ship stationed off the coast just minutes later. The next mission carried a set of second-generation communication satellites for a commercial partner, marking the third mission SpaceX has flown for that particular customer. Packed inside the payload fairing were 3 of those satellites, launched atop a booster flying its 30th mission, which landed successfully on a separate drone ship shortly after liftoff. Because of how the payload adapter was configured, there wasn't much to actually see during the deployment sequence itself. So SpaceX ended the live broadcast shortly after the booster's landing, with successful satellite deployment confirmed a little while later through separate updates. Beyond the routine Falcon 9 cadence, there was also a much more distant story making headlines this week, involving a Falcon 9 upper stage striking the surface of the moon. Despite some sensationalized coverage online, this was an entirely expected event that occurred exactly on the predicted schedule. The stage in question was the same one responsible for launching a notable lunar mission carrying both a NASA-funded lander and a Japanese company's lander toward the moon back in January of last year. Those payloads were placed into a high orbit that carried them most of the way to the moon, and once that upper stage had expended its propellant at that distance, there was no fuel remaining to perform any kind of controlled disposal maneuver. Instead, the stage was simply left to gradually be pulled in by lunar gravity over time, eventually resulting in an uncontrolled impact on the surface. Footage shared publicly captured the visible spread of ejected material from the impact, and separately, a South Korean lunar orbiter managed to capture before and after imagery of the impact site from orbit, offering a clear visual comparison of the surface before and after the strike. There's also a fresh round of lunar-based development updates worth covering. Building toward a permanent lunar outpost is an enormous undertaking, expected to require more than 20 separate landing missions just to complete the first phase alone. Each of those missions will deliver new equipment, technology, and scientific instruments that gradually build up the outpost's overall capability, and the hardware needed for several of those early missions is now visibly coming together. On the West Coast, one lunar lander company, recently acquired by another aerospace firm, has its next lander arriving at a NASA facility in California for environmental testing ahead of a mission targeting the lunar South Pole. That lander's set to carry 10 separate payloads, including a rover developed by a robotics partner. It's currently mounted on a specialized fixture that allows engineers to carefully measure its total mass and center of gravity, data that's essential before the lander launches later this year aboard a Falcon Heavy rocket. On the East Coast, Blue Origin continues making progress with its own lunar lander program following thermal vacuum testing completed earlier this year. After being shipped back to Cape Canaveral, the team has verified the lander's compatibility with both NASA's satellite tracking and relay network and NASA's Deep Space Communications Network. They've also tested how the lander behaves during separation from its New Glenn launch vehicle, completed acoustic testing, and are preparing to begin testing of the cryogenic propellant system next. The actual flight engine that will power the lander down to the lunar surface has already passed successful fit checks, which is genuinely encouraging news, even as the broader program continues waiting on repairs to its launch site infrastructure. Blue Origin also shared new details from its ongoing investigation into a recent launch vehicle anomaly, reporting that a fault in the main oxygen valve on one of its main engines was responsible for triggering an explosion. The company is now testing every engine of that type to better understand the underlying issue and has already implemented modifications to the valve design. They believe those repairs can be retrofitted onto existing engines already built, meaning there's likely a substantial amount of additional testing still ahead. The lunar lander's launch is currently targeted for the first quarter of 2027, and the hope is that these ongoing repairs and design improvements stay on that general timeline. There's a lot of genuinely interesting science planned for that mission as well, including a set of stereo cameras specifically designed to study how the lander's engine exhaust interacts with the lunar surface during descent. Data that should prove extremely valuable for refining engine and lander designs for future, considerably heavier lunar landers. Meanwhile, just north of Austin, Texas, Firefly Aerospace is preparing for its second lunar landing mission, with that lander now fully stacked and the team preparing to install its electronics and payload units. Before launch, the lander will be mounted on top of a separate orbiter spacecraft, and together the combined stack will stand about 22 feet, or close to 7 meters tall, more than 3 times the height of the company's first lunar lander. This particular mission is targeting a landing on the far side of the Moon, which is exactly why the accompanying orbiter is necessary, since it will serve as a communications relay between the lander and Earth. The mission also carries a radio astronomy payload designed to take advantage of the fact that the Moon itself blocks essentially all radio interference originating from Earth, giving scientists an unusually quiet environment in which to study faint radio signals arriving from deep space. In Houston, meanwhile, Intuitive Machines is assembling its third lunar lander for an upcoming mission, with the vehicle's methane tank now mounted on top and its oxygen tank installed below. It's genuinely notable to see 3 separate lunar lander missions being prepared simultaneously across different companies in different parts of the country. Beyond these individual missions, some of these same partners are also teaming up on a set of new lunar technology demonstrations planned for an early phase of NASA's broader Artemis program. The plan involves repurposing power, avionics, and communications hardware originally developed for an earlier lunar space station module and testing those same systems directly on the lunar surface. Instead, a smart way to reuse already proven hardware while validating the technology needed to support future crewed and robotic missions. A handful of smaller updates round out the week as well. One commercial space station company shared striking footage of astronauts training for lunar geological fieldwork underwater, with 2 NASA geologists suiting up inside a large indoor pool facility to practice the kind of fieldwork planned for the lunar surface. During that training session, they tested prototype geology tools and deployed a mock lunar science payload, all conducted under carefully controlled low-angle lighting designed to simulate the harsh lighting conditions expected near the lunar South Pole. The exercise is part of a broader effort to refine both the equipment and the procedures ahead of a future crewed Artemis mission. Separately, Relativity Space announced that the first stage of its next-generation Terran R vehicle has completed structural qualification testing, including 420 pressure cycles. During that testing, while pressurized, the stage was subjected to roughly 4.3 million pounds, or close to 2,000 metric tons of compressive force. With that milestone complete, the company can now move forward with confidence that the stage's propellant tanks are structurally capable of withstanding the loads expected during ground operations, launch, and flight. Rocket Lab also had good news to share this week, having been awarded a contract worth roughly $397 million from the United States Space Force to build a series of advanced satellites intended to launch aboard the company's larger Neutron rocket. Because these particular satellites are being built for the Space Force, the public likely won't get much visibility into their design or operation once complete, but it's still a meaningful sign of confidence in Rocket Lab's larger rocket program even before that vehicle has flown for the first time. There's still hope that Neutron's maiden flight could happen before the end of the year, though there remains a considerable amount of work left to finish before that becomes possible. On a related note, Rocket Lab's smaller Electron rocket also returned to flight this week, following an unusual launch abort roughly a month earlier that the company didn't provide much additional detail about. This latest mission carried another radar imaging satellite for a commercial partner, part of an ongoing contract that still includes 10 more radar satellites to be launched, eventually building out a full constellation of 36 spacecraft. Interestingly, no onboard footage was shared from the early part of the ascent this time, with camera views only becoming available after stage separation. Later in the mission, the rocket's kick stage successfully deployed the satellite roughly 50 minutes after liftoff, wrapping up another genuinely packed week across the commercial space industry. Taken together, this stretch of updates captures an industry moving forward on an almost overwhelming number of fronts simultaneously. A flagship recovery effort in the Indian Ocean that isn't going entirely to plan, a next-generation Launchpad already being refined after only 2 flights, an enormous new manufacturing facility being proposed at a scale that's genuinely difficult to visualize, a steady rhythm of Falcon 9 missions continuing largely in the background, 3 separate companies simultaneously preparing lunar landers for launch within the same general window, and a competitor working through the aftermath of a serious engine failure while still holding on to an early 2027 launch target. None of these threads exist in isolation from each other. They're all unfolding across the same industry during the same stretch of weeks, each one depending in some way on hardware, infrastructure, or milestones achieved somewhere else in the broader picture, and each one moving the overall pace of commercial spaceflight forward just a little further than where it stood before. There's also something worth noting about the sheer breadth of scale represented across these stories taken together. A single vehicle drifting slowly through rough ocean swells at the mercy of wind and current sits at one extreme. An almost improvisational, hands-on recovery effort playing out in real time with no fixed script to follow. At the other extreme sites a proposed manufacturing facility, spanning millions of square feet, planned years in advance down to its highway interchanges and site layout. In between those two poles are lunar landers being carefully measured for center of gravity on specialized fixtures, rocket stages being crushed under thousands of tons of test force, and satellites being built for a military customer that will likely never be photographed once complete. It's a genuine reminder that an industry moving this quickly doesn't move in one uniform direction or at one uniform pace. Some parts of it are still fundamentally hands-on and reactive, chasing a drifting spacecraft across an ocean with tow lines and marine fenders, while other parts are executing multi-year infrastructure plans on a scale that wouldn't look out of place next to a small city. Both of those modes are happening at the same companies, often in the same week, and both are equally necessary for getting from where the industry stands today to the kind of daily launch cadence being discussed for just a few years from now. Whether that ship ever makes it back to a shipyard in Texas or ends up documented and dismantled somewhere along an Australian coastline, the broader machine driving all of this forward clearly isn't slowing down to wait and find out.